Alright, this video is going to be short and it's just about a few things that are going to show up on your homeworks and labs, and you'll need this information for those things. So the first thing is called precedence, and it has to do with the order of operations. And if we look at the back of the book, there's an appendix that has a precedence table in it, and you can think of precedence as how you would draw the parentheses around an expression. So for example, this x plus y plus z, really, if you follow the order of operations of math, that should happen, the x plus y should happen before you add all that to z, right? You're going to draw parentheses like this. And it's this process of drawing parentheses that is precedence. All right, so maybe I should write that. And here are some examples that we'll go through. Precedence, order of operations. And for us, that's going to mean how the parentheses get drawn to just explicitly say how those things are going to execute, in what order. So, if you remember from maybe math class a long time ago, you had that order of operations, PEMDAS or whatever. Everything that's in parentheses, then exponentiation, multiplication and division, addition and subtraction from left to right. So you would use that kind of order of operations to draw parentheses like this. So the first thing that's going to happen is this multiplication operation from left to right. Here's another one. And then we have division as well. So that'll happen before this final output. That's the plus. So that's how you would draw parentheses to explicitly say what's going to happen and when. Explicitly tells what's going to happen and when. All right. So what I want you to be able to do is to look at the precedence rules for not just math, but for C++ itself, which has the math rules inside of it. Using this table, I'd like you to be able to look at it and see how to draw these parentheses. So it works from high to low. If I just zoom out for a second, these operations, they have different groups, and these ones have the highest. This particular operator has the highest precedence, and that's these two colons, which we don't really use in this class because we use namespace std. And then these are all at different precedence levels. All of these things in each box are at the same order of precedence, so they each get done at the same time. All of these things, and then you have your normal math rules: multiplication, division, remainder, addition and subtraction comes after that, and these are all from left to right unless they say otherwise. Okay, so let's use this table on this first example. Can I erase maybe? Let's see. We're just going to redraw these parentheses, really, just using the table though. Okay. So let's find the first operator that we see in the table from top to bottom. So there's three operators that are different. We have two multiplication operators and one plus and one division operator. Okay? So let's figure out which of those come first. Notice that this is called a unary minus and a unary plus, and that's like changing the sign of something. That would be like minus 5 or plus 3 just by itself without anything. 3 plus 5 and 3 minus 5, the plus and the minus here, these are binary operators, okay? Unary plus and minus. Oops. And these are binary, plus and minus. Binary, like they take two things. Okay, so with that in mind, there are no unary pluses or unary minuses. There is a binary plus, and so that would be this one way down here, all right? So the first thing that we see are multiplication and division operators. So let's just go in order from left to right. Whichever ones we see first, we'll draw parentheses around them. All right? So the first operation is this multiplication, and what's on the left and what's on the right is our next question. And it's just this x and this y. Okay? And again, following the table, we've taken care of this smaller expression. Now we have to worry about the rest. So what's the next operator at the highest precedence, at the next highest precedence level that we see? Again, from left to right, it's either multiplication or division. We see the multiplication operator first, so we look at it and say, and ask what's on the left side. It's this x times y. What's on the right? It's just the z. So then we'll draw the parentheses like this. So this whole three-step process of multiplying x times y times z happens the very first. That's the first step, the first couple steps that are going to be executed when the computer tries to evaluate this big long expression. First it does x times y, then it takes whatever that was and multiplies it by z. That's what the parentheses are trying to say. And then we look and see what the next highest precedence operator is left that we haven't put inside of any parentheses. There's a plus and then there's a divide, and divide happens to be the highest one that we see still. So we'll draw the parentheses like this because the 7's on the left-hand side and the 2's on the right-hand side. And then finally, we have the plus. So this whole big thing is on the left, this whole big thing is on the right. I don't have to draw any final parentheses. That just is unnecessary, right? So at the very end, we found exactly the order in which this expression is going to be evaluated. And we use that by looking at the precedence table and finding the highest operators first. All right? So, following this pattern, let's do a much more complicated example. Look at all the operators, plus, times, greater than is an operator, and is an operator, not equals, or, minus, equals, division, multiplication. So let's find the highest one. Just scrolling down, it looks like we have, again, multiplication and division and remainder at the highest level. I don't see anything above. So let's work on multiplication and division and draw those parentheses first. So that means this multiplication operation is going to be the first thing that it binds the tightest, we say. And so we're going to draw parentheses around what's immediately to its left and immediately to its right. So y times z happens, and that gets added to x, which is how math would tell us that this works, right? And then again, we see multiplication and division, just from left to right. We'll do like that, and then like that. Okay? And then, so we've taken care of all this stuff in parentheses now. So looking at the table for the next highest thing, we see addition and subtraction. We have some of those operations. So let's do the addition. From left to right, there's an addition operation. Here's a subtraction operation. What's on the left-hand side is the z. What's on the right is the w. Okay? And I think that covers all of those. So the only things we have left are the greater than, and not equal to, or and equal to. So let's see which ones are higher than the others. So it looks like the less than and greater than and less than or equal to, greater than or equal to come before the equals. So we're going to parenthesize all of those first because we don't have any like CNs or COUTs. We don't see any of these operators. So let's do the greater than. What's on the left? This big thing. These parentheses are getting unwieldy now, but it still makes sense. And that's the only thing within that category. So now let's handle the equals and the not equals. All right. So not equals is at the same level, it comes first. And then equals, from left to right, what's on the left? This. What's on the right? This big thing. I'll draw the parentheses like that, and now the only things that are outside of parentheses are the and the or, and we need to know which one comes first, because this is going to be very important when you're writing big long if statements. All right, so it looks like and, we say and binds tighter than or. You draw the parentheses around the ands first before you worry about the ors. So that means the and, what's on the left? Sorry, is going to be this. What's on the right is just this right now, not the whole thing. It's always the closest thing. So that means this OR is at the very outer level, and so we're ORing together this big thing with this big thing, okay? So that was a very complicated example, but we just followed the table and we were able to pick out the operators and figure out what's on the left, what's on the right, and draw the parentheses just fine. So a simpler one, just to give an example of and OR, because those are going to come in handy a lot when you're coding. Let's do these first. So if I just follow the table, I see remainder at the highest level, draw this, and then I see equals and not equals, and those come before and OR. So I'll draw parentheses around those. And now I need to pick, is it going to be like this? Because I have two options, right? It's either OR, then the AND, or, and this will change the truth value probably, it's either this and that, or this or the AND together. Okay? There is a big difference. And it turns out that it happens to be the AND binds tighter, and so we'll draw the parentheses around the AND operation first. So it was like this, and now the OR is at the outer level. So this is how all of these things are going to get executed. And if I gave you examples now, like saying x was 5, you can plug it in and see exactly what's going to happen now. Is this true? No, so it evaluates to false. Or is it odd, true, and is it not 7, true? So this becomes true, or false is still true, so that makes it true. Okay? So if I gave you an example like this, you could plug in the numbers and get the right answer. All right, so that is precedence. It's just the drawing of parentheses and following this table. I'd give you this table on an exam or something. I wouldn't make you memorize it, but just remember that everything like this is at the same level as each other, all these operators, and you'll do them from left to right, whichever one you see first, and then move on to things at lower precedence levels. Okay, so that's precedence. Now I want to talk about just much quicker things. So here is an example from last lecture, our FizzBuzz example, and when something went wrong with the arguments, we said to the user, you gave the wrong number of arguments, you should have done it like this, and then we stopped the program. Really, this is a special kind of output. This is an error, right? We're trying to output an error here. And so if I copy this file into today's lecture, 409, FizzBuzz cerr.cpp, I can change this to, instead of couting here, I can say something called cerr, because IOStream doesn't just give me cin and cout, it gives me 3 things. The third thing is called cerr, which is used for error output. Cerr is used for error output, and it works just like cout. But if anybody is like looking at the output of your terminal, they'll be able to tell, a program at least will be able to tell whether or not you outputted to cerr or to cout. This will look the same as using cout to humans, but not to your terminal. Okay? So really, using cerr, it's a good strategy, and you'll be doing this in your labs, it's a good strategy to use cerr for any error output, because you can just get the error output only from your terminal if you ever want to. Let's see here. I can run this and just show you that it looks the same. If I cd into 04-09, get to this file, g++, FizzBuzz cerr.cpp -o FizzBuzz cerr. And the error only happens when I don't give any arguments. So if I gave 5, it would work. But if I don't give any, it'll give me the error. And it looks the same as using cout, but it's outputting to something special, a special different kind of file stream called cerr that I think, if not in your textbook, it'll be in a later lecture about cerr. Okay, so you can use cerr just like cout, but it's used for error output. Okay, and then the very last thing that I want to talk about is something very simple. It's just another way of making of declaring variables. And this is called using constructors. So I'll call this maybe constructors. And so if you ever see like an example of this in your homework, you'll know what it's doing. So the normal way, excuse me, the normal way in C++ to declare a variable and assign to it in the same line is something like this. Declares x with a value of 5. There's another way to do it. Int y 5. And it looks like you're calling a function in a sense. Declares y with a value of 5. And you can do this with other types as well. Double, D, 3.14, E. What is E? 2.7 something. And then, yeah, you can declare multiple things on the same line. And this is just a new type of syntax to both declare and initialize at the same time. And if you go further, sorry, if you go further in your programming career, you'll be using things called constructors, and this will make more sense later, I promise. Declares D and E with the given values. This is called, this syntax is called constructors. Using the syntax is using, maybe I'll just say, this is constructor syntax. That's the best phrase. Okay. And of course, these are all doing the same thing. Let's see out x, it's 5, y, d, and e. And they'll have all the values that I gave to them. It's just another way of initializing a variable. You cannot do this ever again. Like you can't down here, I don't think, say like f or e of 7. That doesn't really make sense. It's only when you're initializing does that work. So let's hopefully find that gives an error. G++ constructors.cpp-o constructors. Yeah, so you can't do it like this, but you can. This only works, the syntax, when declaring the variable for the first time. You'll have to use the equal sign, the assignment syntax, after that. Constructors, and it gives back everything we would expect. And yeah, I think that was everything that I forgot to talk about that you needed to know. So I will see you in the main lecture video now.